Hello students, my name is mubashir Hussain. Today we are going to discuss force on a moving charge in magnetic field. First, try to understand one thing that magnetic force only act on a moving charge. Magnetic force does not act on a stationary charge. Electric force can act on moving charge as well as as well as a stationary charge. We will discuss why is this so also. Before going into the detail, listen one thing first. Magnetic force is a field force. Any field force can only act when two fields interact with each other. Same is the case with the magnetic force. When two magnetic fields interact, the magnetic force acts from stronger magnetic field region towards the weaker magnetic field region. And when the charge is at rest, it does not produce its own magnetic field. Therefore, it cannot experience a magnetic force. Now come to the topic. Listen, when this charge is moving, suppose at right side, suppose a positive charge, it will create its own magnetic field. You can see in red circles according to right hand rule. These red circular lines indicate the magnetic field produced by this moving charge. And I place a strong magnet near it. This black magnetic field lines are external magnetic field lines. Now these two magnetic fields will interact. This red magnetic field produced by a moving charge. This black magnetic field is external applied magnetic field. If you can see one thing, that these red magnetic field lines are in the downward direction and black magnetic field lines are in the upward direction from the front side of this board, not from the other side of the board. That will be the other case. So at the front side, these two magnetic field lines are in opposite direction. Therefore, they will cancel out each other's effect. Hence, the net magnetic field is weak at the front side of this board and strong at the back side of this board. Therefore, the magnetic force will act from stronger magnetic field region towards the weaker magnetic field region. Hence, this charge will face a push, a force outside of the board. I will explain the phenomena with the help of these rules also. This is the formula for the force acting, magnetic force acting on this charge. I am not giving derivation of this formula right now because I am going to make a short video here. In vector form and in magnitude form, this is the force experienced by this moving charge. The magnitude of the force depends upon magnitude of charge, velocity of charge, magnetic field strength, and the sign of angle. This angle is between velocity and magnetic field lines. Hence, if a charge moves parallel or anti-parallel, it will face no force. But if it moves perpendicular to the magnetic field, it will experience a maximum force, and so on. Now let's discuss the rules. How can we check in which direction will the charge be deflected? There are some rules. The first of all, right hand rule. Right hand rule is very famous and it can be applied to every cross product. You can see force is cross product of velocity and magnetic intensity. Torque is a cross product of position vector and force. Angular momentum is a cross product of position vector and linear momentum. So direction of every cross product can be find out by right hand rule. What is the rule? Align your fingers in the direction of first vector. My velocity is at the right side. and rotate your fingers through shorter angle towards the next vector. Magnetic field lines are upward, velocity was in this direction, so I will align my fingers first towards the velocity and then curl it towards the magnetic field line. Thumb indicates out of the board. Hence, magnetic force is towards out of the board, towards the reader, so on. So this is the right hand rule. There is another rule called right hand palm rule or extension of right hand rule. In this rule, the fingers remain straight. They will not be curled. Keep your thumb in the direction of velocity. Straight fingers in the direction of magnetic field lines, and the force acts along perpendicular to the palm. Perpendicular to the palm. This rule also indicates that the force acts out of the board. Fleming's left hand rule. According to this left hand rule, the index finger indicates direction of magnetic field lines, middle finger indicates the direction of velocity, and thumb indicates the direction of force. So this moving charge will face a force out of the board. All the rules give us the same answer. There is something to understand carefully. This magnetic force on a charge is a velocity dependent force. Electric force is independent of velocity. Hence, it can be applied to a stationary charge, it can be applied to a moving charge. If the charge is slow, if the charge is fast, force does not concern with it. But magnetic force is velocity dependent. It means suppose a charge is at rest and I bring a very strong magnet near it. Will this charge start to move? Obviously no, because it will not experience a magnetic force. If I brought another charge near it, then this under discussion charge will start to move due to electric force. Hence, electric force is accelerating force. It can move a stationary charge. Magnetic force is a velocity dependent force. It cannot move a stationary charge. Magnetic force is a velocity dependent force. Cannot move a stationary charge. I hope you understand the reason. Mathematical reason is this, because velocity is 0, hence force is 0. And physical reason is this, stationary charge does not produce a magnetic field. Hence, the applied magnetic field will interact with none of the fields, so magnetic force will not be detected. For magnetic force to be acted, there should be at least two magnetic fields. Because the magnetic force cannot speed up a charged particle, cannot slow down a charged particle, cannot make a charge to move, cannot make a charge to stop. Hence, it is called non-accelerating force. It cannot change kinetic energy. According to work energy principle, it cannot perform work. So what can it do? It can just change direction of the moving charge. Hence, it is just a deflecting force. It acts like a centripetal force. Just see some examples of the path of motion. If a charged particle enters parallel or anti-parallel to external magnetic field, it will move along a straight line because it will not experience any force. Because sine 0, answer is 0, or sine 180, answer is 0. If it enters perpendicular to the external magnetic field, sine 90 gives 1, means maximum. Hence, it will face a maximum magnetic force, and this charge will start revolving here in a circular path. If it enters at some other angle, neither 0 nor 90, at some other angle, 10 degree, 20 degree, 30 degree, 45 degree, it will make a helical path, because now it want to translate as well as it want to circulate. The combined effect of translational motion and circular motion is helical path. Thank you.